So I told you what is my plan. I told you that I'm planning to finish the fourth module today. And there is only one last concept that is remaining in the fourth module. That is, we have to study what is the meaning of, we have to finish what is the meaning of classes and methods, how to define class level attributes, and then very important concept we have to study, that is the concept of operator overloading. Okay, so that is a concept that we have to study. I will start my screen sharing. So this is my screen, and then let us now start from the beginning. Very quickly, I will revise. I will tell you what exactly we have done. When we started with module number 4, you know that first we started with the classes and objects. I told you the difference between a class and an object, some basic stuff of object-oriented programming. Then I told you about reference. What is an object? An object is a reference. An object is a pointer to a memory location. Okay. And then I explained to you people what is the meaning of alias, and then I told you what is the meaning of shallow copy and deep copy. Then we studied what is the meaning of classes and functions. We can pass objects as arguments to functions and all that. So we've done all this in the previous classes. Now today what we are doing is we are doing the last concept of module number 4, that is classes and methods. In this, what we are going to do is we are going to learn some real object-oriented features of Python programming language. Then we will learn what is the init method, the STR method. Then we will study the most important, the operator overloading. Okay. So now going directly to classes and methods, I will directly go to classes and method, which is over here. Okay. All this time, what we were doing is we were defining classes which were empty. Classes was not having anything in them. We just had one doc string in the class, and all the attributes that we defined, we had defined it for objects. Now today we are going to define some methods at the class level. Okay, at the class level, meaning that we are going to define functions inside a class. Now remember what is the meaning of a function. I told you that a function is a set of statements that is written separately, and then a name is given to it. And then whenever you want those set of statements to get executed, you just call the function by its name and it gets executed. Okay, so this definition of a function is applicable for all programming languages, not only for Python. A function generally in all programming languages is a set of statements that is written separately, and then you give it a name, and whenever you want to execute those set of statements, you just call it by its name. Now there is a difference between a function and a method. Now when you write a function inside a class, it is called as a method. When you write a function inside a class, it is called as a method. How you call a function? By its name. How do you call a method? Through the object. If you want to call a method of a class or a function which is defined inside a class, you have to first create an object of the class, and through the object of the class, you have to invoke the function. Okay, so now by now you know the basic definition of what is the difference between a function and a method. Functions are what we write in a program, and methods are what we write inside a class. Okay, and then how to invoke functions, we directly call it by its name. But how do we invoke a method? We invoke a method, or we call a method by creating an object of that class, and then through the object, using the dot operator, we invoke a method. So basically that is what is given over here. Okay, so you can see here there are things given. Methods are semantically same as functions, only they are same. Okay, but the difference is methods are defined inside a class and all that. Okay, the syntax of invoking a method is different from syntax of calling a function. Why? Because you have to create an object for invoking a method and all that. So now let us learn the first method that is written inside a class. You all know the concept of constructors. You know what is a constructor. A constructor is a special type of a function or a special type of a method that is written inside a class, and users need not explicitly call this method. These methods automatically execute. When do they execute? Constructor methods execute when you create an object of the class. When you create an object of the class, at that time, the constructor automatically gets executed. Okay. What you write in the constructor, everything gets executed. Normally, why do we use a constructor? Constructors are used for initialization. If you want to initialize, give some initial value to the variables of a class, you use a constructor. You pass those arguments to the constructor, and then the constructor will take these arguments and initialize the class variables. In most of the cases, constructors are used for initializing class variables. Okay. Now, how to write constructors in Python programming language? Remember, Python is different. It is not like all other programming languages. In other programming languages, how do we define a constructor? Constructors is just like a function, but the name of the function is same as that of the class. In other programming languages, if you take Java, there, if you define a function with the same name as that of the class, then it is called as a constructor. But in Python, constructors are defined using this syntax here. We write underscore underscore init underscore underscore, two underscores before the init word and two underscores after the init word, and then your simple parentheses. That is how we define a constructor in Python programming language. In Python, you can have constructors without parameters or with parameters also. You can have any number of constructors in your Python program. But all the time, remember that the name of the function should be the same, underscore underscore init underscore underscore. This is the syntax of defining a constructor. Now, immediately, okay, there is one example that is given over here. If you remember the point class, okay, what we do is we define the class here, and then we define a constructor. Def, you know how to define a function in Python. We always write def, def, define, def, followed by the name of the function, and then the parenthesis inside which we write the parameters. So def underscore underscore init into bracket, we write down self, comma a, comma b. Then we have one more function inside the class here called as dist, which will find the distance between 2 points. Okay, and then here also the parameter that is passed is self, comma p2. And then there is one more function which is defined over here down, which is called as underscore underscore str underscore underscore, and then there is parenthesis, and then there is parameter called as self. If you see all these functions here, all these methods here, which are defined inside the class, has got one common parameter called as self. Self is the first parameter that is passed to all the methods, okay, which are defined inside a class. Now this is compulsory. Please remember that all the methods that are defined inside a class level functions, class level methods, the first parameter should always be self. Now what does the self represent? The self represents the current object. Self here represents the current object, the object which is invoking that method. If I say that self represents the current object, the object that is invoking the function, right now just remember only this sentence. Self represents the current object, the object that is invoking the method. Later on with an example you will understand what does this self represent. For example, let us say I create an object of point P1. Okay, I create an object P1 of class point, and then using P1 I can invoke dist function, distance function I can invoke. P1.dist I can invoke because dist is an of a function of point class, and using the object of point class I can invoke the dist function. So when I invoke the dist function, remember I'm invoking it using which object? P1 object. So P1 gets copied into self. So whatever I do to self is actually coming from the P1 object. So here self actually represents the current object, the object which is invoking this function. We will take an example on this, we'll understand. Okay. Now, if you want a little analogy of how this is used in other programming languages, I hope you remember from Java and C++, there is a pointer called as this pointer. The this pointer actually represents the current object, the object which is invoking the function. Same, here we use it as self. In Python, the this pointer is called as self pointer. It means the same. In C++, and in Java, it is called as this pointer, but here in Python, it is called as the self pointer. Self represents the current object which is invoking the function. Okay, let us take an example of this and let us see this later on. Okay. Now, I have a look at this point class. I have a class called as point, and then there is a constructor called as init. I define init, pass self a, comma b. Two parameters I'm passing explicitly. Now remember, when I call the function, I'll look at this example first. I will come to it later on. When I call this particular function, when I call this function distance, how many parameters it is taking? It is taking two parameters. The first parameter is self, and the second parameter is p2. Okay, it's called as p2. So what does this distance function do? It will find the distance between the point which is calling this function dist and the point p2. The dist function is taking two parameters, self and P2. What will this function do? It will find the distance between the object. The object has to be an object of point only. So the object P1 and P2, it finds the distance between these 2 points. Okay, by finding the Euclidean distance. If you remember, we had written this program to find the distance between 2 points. You have to pass these 2 points as the parameter to the function, and then you can calculate the distance between the 2 points. So this dist function basically finds the distance between the 2 points here. The first point is self. Self is the object which is calling it, and second is P2. Now here, if you look at this, when you call the function dist, when you create an object of, for example, you can see it here. I create an object P1 point, pass 10 and 20 as a parameter. So 10 gets copied into X, 20 gets copied into Y. So P1 is a point whose X coordinate is 10 and whose Y coordinate is 20. Similarly, P2 is a point whose X coordinate is 4 and Y coordinate is 5. Okay, after that I print P1 and P2, and then finally I want to find the distance. So what I do is I do P1.dist P2. Now this is an example. This is an example where you understand what is the meaning of the self. When I do P1.dist P2, when I call P1.dist P2, what I'm doing is I'm invoking the function dist using which object? P1 object, and to which I'm passing a parameter P2. Now if you see that the dist function here, I am passing how many parameters when I'm calling it? Only one parameter I'm passing. But here when I've defined it here, when I've defined dist here, there are 2 parameters. Why? Because self parameter comes implicitly. Implicitly means internally. You don't have to mention that. In self, what gets copied? P1 gets copied. Because you're invoking the function dist using the P1 object. P1.dist, P1 gets copied into self automatically. But the second parameter, you have to pass it explicitly. You have to pass it explicitly. Explicitly means you have to mention it. The user, when they are calling the function, they have to mention what parameter they are passing as a second parameter. First parameter will automatically go. What will go? P1 will go, because P1 is invoking the function dist. So P1 will automatically get copied into self. P2 has to be sent explicitly. Now what will happen is when I say P1.dist P2, P1 gets copied into self, and P2 comes into P2, and then I find the distance between P1 and P2, and then what comes back to me is the distance between the 2 points. I hope this is clear. So when we define a function, remember all the functions should have the first parameter as self. The self represents the object which is invoking that function. This self need not be passed when you are calling it. The other which are there has to be passed explicitly. So that's the reason why if you look at this init function here, it's a constructor. How many parameters are there to the constructor? 3. 1, 2, and 3. Self, A and B. A gets copied into the X, B gets copied into Y, A gets copied into X, B gets copied into Y, A and B, and then self is also there. Self means the current objects X has to be initialized to A, current object Y has to be initialized with whatever values passed as B. So when I call this constructor, when I create an object of the point class, when I call this constructor, see, you can see it here. What I'm doing is I'm simply writing P1 is equals to 0.10, 20. I'm writing P1 is equals to 0.10, 20, which means that 10 gets copied into A, 20 gets copied into B. Okay, so 10 finally comes into the X of P1, 20 comes into Y of P1. I'm initializing the X and Y coordinates of the point P1. Similarly, when I create another object P2, 4 gets copied into A is put into X of self, X of P2, B gets copied into Y of self is nothing but P2. So P1 X is 10, P1's Y is 20, P2's X is 4, P2's Y is 5. So remember that the function here in the class should take self as the first parameter always when you are invoking it through the object, and that self represents the current object which is invoking the function. Okay, I hope this is clear. So this is a concept of the init self, and there is one more function here at the end called as underscore str underscore, and then there is a self that you pass here. I will tell you what does the function do. Let us first go through this program and see what happens. Okay. I declared 3 functions here. One is a constructor, one is a distance finding function, and this last one is an STR special function. This function does something special. I will tell you what it does. When I create an object of P1, it immediately calls init function. So you can see here P1 is equals to 0.10, 20. The init is called automatically, of course, because object is created, constructor is called. P2 is equals to 0.4, 5. Init function is called internally. Init function is called internally because it is a constructor, object is created. After that, what I do is I simply say print. I use a function of Python print. What does print do? Print will display something. So I said print. I said print P1. I said print P1. When I said print P1, remember P1. What is P1? P1 is actually a special type of a class. It's a special class object P1. It is not a normal variable. Do you think P1 is an integer or a string? If you say print into double quotes, if you type P1 is, it will display what is in double quotes as it is, you know that. But after that, I'm putting a comma and I'm displaying P1 here. What do you think? P1 is a simple integer variable, that the value of this integer variable will be displayed? No, it is an object. So when you display an object, you know what happens. In the previous examples, you saw that when you display an object, okay, it was displaying, it is an object of which class, what is the memory location of that, all that you saw, it is on the top there. Okay, in the previous sections we have seen that when you print an object, it displays all. But if you want something special to be displayed, when I print P1, if you want something special to be displayed, then you define a function in the class called as __str self. And whatever this function returns back, str returns back, that comes here and that will get displayed. So the STR function is basically used for converting an object into a meaningful string. So whenever, if you want your object is displayed using the print function, if I say print P1, it is an object of my class. And if whenever anybody prints an object of your class and you want something special to be displayed, that something special has to be written in the STR function. STR function self, whatever you return from here. What is this function returning, by the way? If you see, what is this function returning? The function is telling that please return back a string. Which should contain integer here, comma, integer into bracket. And then what should be substituted in that $%d here? Self.x and self.y. So the current object x value and the current object y value should be returned back. What we are writing, what code we have written in the STR function, the code that we have written in the STR function is that whenever anybody prints the object, it should print the x value of that object and the y value of that object to return that back, and it displays you the x value and the y value. So when I say print, P1 is P1, I'm printing P1 here, print P2 is P2. When I'm printing this, remember the STR is called automatically. The STR function is called automatically. This function is called, and in the place of P1, the x value and the y value of P1 is displayed. When I print P2, the x value of P2 and the y value of P2 is displayed. Okay. So if we go further, and try to see how to invoke the dist function, I define what is this function returning back. The function is returning back the distance between the 2 points. It is returning back the distance between the 2 points. Dist function is returning the distance between the 2 points. So I write d, I want whatever is returned back, I want the distance between the 2 points to be kept into the variable d. So I write d is equals to p1.dist p2. P1.dist p2. So now the function dist will be called, P1 will be copied into self, P2 will be copied into P2, and then the distance between the two will be calculated and it comes back into dist. And finally, that is what I'm displaying. Print the distance is d. Remember, distance is a simple variable. Distance is an integer. Okay, integer or a float, because the distance between the 2 points will either be a float or an integer. So it is not a special, it is not an object. D is a simple integer or float value that comes back from the function dist, and that is what you are displaying. The distance is d. So the output will be like this. First, it will display P1 is 10, 20 because of this statement here. Print P1 is P1. P1 is 10, 20. And second line, print P2 is P2. So it displays P2 is 4, 5, the second point, and then finally it displays the distance is 16.15549 and all that. So this is the output of the program. So what have we understood from this? We have understood that when you write a class contains two special type of functions called as a constructor, which has to be always underscore init, init, init underscore into bracket. If it contains parameters, you write the parameters. Otherwise, you can keep it without the parameters. Okay. And STR function underscore STR underscore. You have to pass self to it, and then whenever anybody displays the object of that class, whatever is returned from here can be displayed. Okay, that is why we write the STR function. And then there is a function written as dist, which takes one parameter, and self is by default. So one thing we understood here is that all the functions should take one parameter, that is the first parameter of type self. Self represents the current object that is called the function. Okay. Now that this is clear, let us go further. Right? An explanation about all that is given over here. Keep in mind that every method of any class must have the first argument as self. That I've already told you. Keep in mind that every method of any class must have the first argument as self. The argument self is a reference to the current object. That is, it is a reference to the object which is invoking the method. Okay. So all that explanation about the program which we have written on the top here is given here. You can go through this and try to understand what is that. Okay, and explanation to the dist function is also given, and yeah, and then the concept of operator overloading. So in the first section, what did we study? We studied how to define functions inside a class, and then how to invoke them. All that. In the examination, if they ask you a question, the question will be like they will ask you a question as to explain with the help of an example program how are class level functions defined, or how are methods in a class defined. So you have to write that previous example of the point. Now coming to the most important concept, I'm sure in the examination they will definitely ask you this question. They will ask you to demonstrate with the help of a program operator overloading in Python. So you have to write a little explanation to what is operator overloading, and then after that you have to write an example. We have studied this concept of operator overloading in many programming languages like C++ has it, Java has it, and all that. But what exactly is this operator overloading? In simple terms, let me tell you that operator overloading, what is the meaning of overloading first of all? Overloading is a polymorphic behavior. Polymorphic means one particular thing behaving in multiple different scenarios. One particular operator plus, I can use it for addition of integers also, and I can use it for doing something else also. So when you are assigning two different tasks to a single operator, you are overloading that operator. You are telling that operator to perform two tasks. Okay, when you assign two tasks or more than two tasks to an operator, you are assigning two tasks to an operator. You are making it do two different tasks. Okay, depending upon the parameters that you pass to it or the arguments that you pass to it. We will understand about what is this argument. We will discuss about all that later on. But right now, as a definition, what is operator overloading? Operator overloading is a concept in which we assign multiple tasks to a single operator. Okay, and this is a polymorphic. When anything is doing two different tasks, when multiple tasks when they are performing, it is called as polymorphism. You know what is the meaning of a function overloading? Function overloading is a concept where one class can contain multiple functions with the same name. Function overloading is a concept where a single class has got many functions with the same name. Okay, so polymorphism is having something multiple. Why do we call operator overloading as polymorphic nature? Because you are allowing one operator to perform multiple tasks. Why we call it as polymorphic nature? Because you are allowing or you are assigning multiple tasks to be performed by a single operator. Okay, which are the different types of operators that we can overload in Python? All basic operators like plus, minus, star, less than, greater than, less than, equals to, all that we can overload. Okay, to overload an operator, we need to write a method within user-defined class. Now in Python, it is a little different. In all other programming languages, it is different, but remember in Python, it is a little different. Okay, what you have to do is, let us say that you want to overload the plus operator. Okay, let us go ahead only with the plus operator. Forget about all the other operators. What does the plus operator do in a mathematical expression. It performs addition. If I have two numbers, 3 and 4, if I say 3 plus 4, what does this plus in between represent? It represents that please add 3 and 4 and give me the result. 3 plus 4, if I say, what is the output of this 3 plus 4? It will be 7. It will be 7 definitely. 3 plus 4 is 7. So, plus operator here is performing the addition operation. I want to overload this, I want to overload this behavior of plus, okay? And I want to use plus for something else now. I want to use plus for something else now. So I want to overload the plus operator, okay? So if in my Python program, I want to overload the plus operator, if in my Python program, I want to overload the plus operator, then in my function, I have to write a function called as underscore underscore add, add, and then I have to write the bracket underscore underscore bracket. If I want to overload the plus operator in my class, then I write a function. I have to write a function, and the name of the function should definitely be underscore underscore add, add underscore underscore, and then I have to write the parenthesis. Similarly, if I want to overload the subtract minus the hyphen operator, which is used for subtraction, then I have to write in my class a function or a method called as underscore underscore sub, sub underscore underscore, and then bracket. So depending upon which operator you want to overload in your class, you have to write an appropriate function or a method in your class. Not appropriate, you have to write this compulsory method, compulsory function in your class. You have to write down. If you want to overload the plus operator, you have to write this function. If you want to overload the plus operator, you have to write this function here. If you want to overload the minus operator, then you have to write down underscore underscore sub. If you want to overload star operator, which is used for multiplication, then you have to write a function in your class called as underscore underscore multiply. If you want to overload the slash true div. Similarly, for all these operators here, these are the functions that you have to define in your class. You have to write this in your class. Okay, so plus it is add, for minus it is sub, for star it is mul, for slash it is true div, for a percentage it is mod, for less than it is LT, for greater than it is GT, less than equals to is LE, greater than equals to is GE. So these are the function names that you have to define in your class, and these are the operators. Okay, now this file is already there with you. You can see this and you can by heart. This is important. This table is very, very important to remember this. Okay. Now that we have understood what is the meaning of operator overloading, then let us take an example and go ahead. Let us take a simple example. Let us take a very, very simple example. If you remember the point class has got two attributes x and y, x coordinate and y coordinate of a point. I want to write a program to overload the plus operator. I want to write a program to overload the plus operator, which will perform the addition of 2 points. If I have 2 points, P1 and P2, if I have 2 points, P1 and P2, I want to add these 2 points. I want to add the x of P1 with x of P2 and y of P1 with y of P2, and then finally come up with the addition of these 2 points, and a third point should be given to me. Simple. I want a third point, which is the addition of P1 and P2. X of P1 should be added to x of P2, y of P1 should be added to y of P2, and then a third point should be given to me. I want to perform this operation, addition of 2 points. I want to perform this using operator overloading. So how do I do this? I first of all define a class called as point. I define a class called as point. Then I have a constructor here. I have a constructor here. You can see init underscore underscore init self, and then a is passed, b is passed. So whatever values I give to the constructor, that will be assigned to the x and y of that point. If I don't give any values, then zeros should be assigned. Zeros here represent, please, if no values are given, assign it with zeros. Then I have a function here called as underscore underscore add, underscore underscore self comma p2, self comma p2. I am defining a function called as add, and you know why do we write this function add? Because I want to overload the plus operator. So that's why I define this function add here. So when I define that function add here, you can see that define underscore underscore add self p. And what does this function do? What does this function do? Let us look at this. It will define a point called as p3. It will define a point called as p3. P3 is equals to point. It's a new object, and then p3.x is equals to self.x plus p2.x. So self is nothing but the object which is invoking this add. Self.x plus p2.x, self.y plus p2.y is put into p3.y. So I get a new point called as p3, I get a new point called as P3, which is the addition of x of P1 and P2 and addition of y of P1 and P2 and then put it to P3. So this function add here performs the addition of P1 and P2 and puts it into a third point called as P3. It creates a new point P3, which is the addition of P1 and P2. And what is this function? This is not a simple function. It is underscore underscore add underscore underscore, which is actually for the overloading the plus operator. And then finally you have this STR function here, which I have already explained to you. Whenever it would display the object, it will return back the x coordinate of that point and the y coordinate of that point. Now let us go further and see this. I define a point P1 is equals to point 10, 20. So I define my first point. I define my first point P1, which is present at x coordinate 10 and y coordinate 20. So point constructor will put 10 into the x of P1 and 20 into the y of P1. Similarly, I define one more point called as P2, which is equals to point of 4, 5. 4 gets copied into the x of P2 and 5 gets copied into the y of P2. So I have defined 2 points here. Then what I do is print. I want to print P1. So when I say print P1 is P1, print P2 is P2, it will display me the values here. And here remember that the STR function will be called P1's x and y will be displayed, P2's x and y will be displayed. Then look at this. This is a very important statement here. I perform P4 is equals to P1 plus P2. I do P4 is equals to P1 plus P2. What do you think? This P1 is a simple integer variable. Is this P2 a simple integer variable? It is not. They are objects. So when I use the plus operator here, and if the operands are these which are written before and after the operator. If the operands P1 and P2 are they simple integer variables? No, they are not simple integer variables. They are objects. And have I defined any overloading method for plus in my class? Yes, I have defined. So when I perform P1 plus P2, remember the add function will be called. See here, it says call for add method. The moment I perform P1 plus P2, when I perform P1 plus P2, which function is called? The add function is called. This function is called. And it performs the addition of P1 plus P2. What happens when I perform the addition of P1 and P2? X of P1 will be added to X of P2, Y of P1 will be added to Y of P2, and then finally what is returned back? A third point is returned back. I return P3, which gets copied into P4, and then after that I print P4. I print P4. And then what should get displayed here? P1 is 10, 20, P2 is 4, 5, and the sum is 14 and 25. Why 14? 10 plus 4 is 14, 20 plus 5 is 25. So the third point that is given back to me, the addition of the 2 points is 14 and 25. 14 and 25, which is the third point. And who is performing this addition? The operator plus is performing this. So when I use the plus operator, and the operands are objects of that class which has overloaded plus. If I use the plus operator, and if the operands are objects of the class which has overloaded the operator, then the underscore add function is called. Okay, and then it performs the addition of the objects. Now you can see further the meaning actually of P4 is equals to P1 plus P2 is that it is P4 is equals to P1 dot underscore add P4. Actually, this is the meaning of that plus operator. But instead of writing this, you can simply write P1 plus P2. We can perform the addition of these two by executing this special code which we have written here. So the plus operator executes the function here and whatever code you have written inside. Why will plus behave like that? Because the operands are object of a class. If let us say further, okay, which is given over here. Okay, however, if I would have written in the same program m is equals to 3 plus 4, if I would have written m is equals to 3 plus 4, and if I would have displayed m, the output would be 7. The output will be 7. Why? Because here to the plus operator I am passing integers as the arguments, integers as the operands. What are the operands here? To the plus 3 and 4. So when 3 and 4 are simple integers, so plus will behave normally. It will add this 2. But instead of this, if I write P1 plus P2, P1 and P2 are not integers, remember they are objects. So it will perform this function. It will perform the overloaded behavior and it will perform the addition of the 2 objects and the result is kept into P4 and the P4 is displayed. That's it. This is the concept of operator overload. So what have we done? We have assigned a new task to the plus operator. If the operands to this plus operator are objects of a class, it should behave differently. It should behave differently. If the operands of the plus operator are objects of a class, it should behave differently and it should execute this function. If the operands to the plus is integer operand, then it should behave normally. It should perform the addition of the two numbers. So plus is behaving in two different ways now. For normal integer operand, it is behaving simple addition, it is giving answer. And for objects as the operands, the operator, it is behaving a little differently. It is executing this function here and performing the code that is written by the user. So now two behaviors from a single operator. This is how we overload operator. And this is the concept of operator overloading. Multiple behaviors from a single operator. Okay. So that's it. That's it about the operator overloading. And finally, that is the end of module number 4. Okay. Now this is a complicated example given here. This is a complicated example given here. This is a simple example. Adding 2 points is a simple example of operator overloading. Further there, he has said that let us consider a more complicated program involving overloading. And in here, what they have done is they have defined a class called as time. And after that, they have added times, they have incremented times, all that they have done. Okay, so this I will do it in the next class. I hope it is clear, all of you. Okay, so please, you have the notes with you. Go through it once again today. If you have any doubts, you can accumulate that, keep it with you. And then finally, please ask me your doubts. Okay, so we'll stop here today, all of you. Okay, have a nice day. Bye-bye.